functions, integrals. So the idea here is not that we're actually going to take, we're not actually going to take the integral of inverse trig functions. We're going to take the integral of all those things that you just learned about and get trig functions out of them. So you just learned that if you have, if you take the derivative of arc sine, you get 1 over the square root of 1 minus x squared, right? So therefore, naturally, or maybe not naturally, but it might make sense, that if you take the integral of 1 over the square root of 1 minus x squared dx, you should get arc sine of x plus c. Right? What's hard about these problems is, in part, the fact that you don't always get what you would expect to get, right? And so these problems are really fun for the AP exam to toss in there because they're sort of unnatural, right? You have these, intervals of x's and, numbers, and then out of them you get arc sine. And they can kind of sneak up on you. So, they're fun and entertaining. I'm not going to write out all of them for you because, you should hopefully be able to grab them from the other one. I will note we don't use all 6 of them. We only ever use 3 of them. Okay? So I guess I take that back. I will write that. We only ever use the arc sine, the arc tangent, and the arc secant. Okay? Because if I have a negative here, there's no need for me to then say, well, that's arc cosine. I'm just going to say that's negative arc sine. Right? So we only ever use the arc, go back here. So we only ever use this one here, and when we use the arc secant, you will more than likely see it as x and not as the absolute value of x. That's okay. We don't make that distinction because usually in the problem what you'll end up seeing is this. Okay, really having trouble here. Arc secant of x plus c, and then they'll tell you x is greater than or equal to 0. Okay? So you can make that distinction. You don't have to have the absolute value if x is greater than or equal to 0. Or if x, or they'll say, they'll put a negative and then they'll say x is less than or equal to 0, or so on and so forth. So they'll break the problem down and use only half of it and not the absolute value. So you'll see the problem solved of it. Mostly because textbooks are lazy and they don't want to have to type the extra symbols. Although you would think it would be easier to just type the 2 lines and not either. Cool? You seem unhappy with that. Okay. Here we go. Okay. Okay, I have all my problems. So, first question. Should I use my arc sine or arc cosines or whatever for this problem? It almost seems like you should, right? I've got my square root of 1 minus x squared here. And this is where the AP exam loves to mess with you, right? And this is where you have to be careful of that distinction. In this case, we don't want to use our arc cosines here, or arc sines or any of them. Why not? Because the x is in the numerator. And what does that allow us to do? U substitution. So this is not one of our problems. This is a U substitution problem. As obnoxious as that is, U equals 1 minus x squared. Du equals negative 2x. Yes. This is a classic U substitution problem. Nothing. Negative 1/2 du equals x dx. Translate the integral.
Negative 1/2. No, it's du over 4.
Yep. How do I integrate this? Yep. So u to the negative 1/2 du. This becomes u to the almost negative 1/2 plus 1. Use the positive 1/2 over 1/2 becomes 2, or cos that is plus c equals negative square root of u plus c, better known as negative square root of 1 minus x squared plus c. Right? So the lesson here, don't look at something like this and assume that you have arc things in it. The AP exam loves to try and trick you here. You can almost guarantee that this problem will have an arc sine answer as one of their options. Okay? Because they want to see if you're taking track of the using it. Okay, but getting back to the problem at hand. Sorry, did I flip that too back? Okay. What about something like this? Still has x up top. Has all kinds of things. Is this an arcsine problem? No. That's good. Okay. The goal with all of these arc sine, arc cosine type problems is that you must, under all circumstances, get it to look like your original one of these. Or, I guess I should say, in a U substituted form. And if you can get it into one of these U substituted forms, here, then you can integrate, but not before you get it into that form. Does that make sense? It must look exactly like this, or you can't integrate. Okay? So let's see if we can make this look like that. Okay? The 1 makes me happy, but the x is sort of unhappy. But x to the 4th, let's see if we can do something with that. I'm going to rewrite this. Instead of x to the 4th, that so didn't work, I'm going to say x to the fourth is the same thing as x squared squared. Does that make sense? Now x squared squared reminds me of my u squared, right? Like my goal in the end is to try and get 1 over square root of 1 minus u squared, right? So if I can make that 1 minus x squared squared, then I could turn x squared into u. Seem fair? Okay. So I'm going to say this is x over square root of 1 minus x squared squared. And then I'm going to make x squared into u. Into u. So I'm going to say u equals x squared. And then I'm going to say du equals 2x dx. Okay, that's promising as well, right? What do we need to do? Move the 2. 1 half du equals x dx. That takes care of that, right? Now what do I have? 1 half on the outside. 1 over 1 minus u squared du. Victory! Right? I can take that integral. 1 half arc sine of u plus d. And I plug in u. Really? I run out of ink. Yeah. You don't ask. Equals 1. We're very confused. 1 half arc sine of, instead of u, we say x squared. Cool? So far, so good. Okay. Okay. Next. Okay. How about this one? Dx over the square root of 4 minus x squared. Now the x squared makes me happy. It's the 1 that's giving me trouble. Right? We're going to make the 1 go away. What do you mean? But then, because remember the goal is to make it 1 over square root of 1 minus x squared, u squared, du. I want to get it 1 and 1. So if I multiply by 4, then I've got more problems, not fewer. It's a good thought. It's not quite the direction we want to head, right? So if I want to make this a 1, and I currently have a 4, how do I get rid of things that don't look like what I want? Yeah, not so much with the erasing of the horizontal lines, sadly. can't take the square root. Can I square it? What do you mean? Tragically no. It will eventually.
I feel like if you separate 4 minus x squared
Into fact, we can't in this case, no. But factoring is what we want to do, but that's not the right factoring for us this time. What we want to do, and this is going to seem really bizarre, and that's what she was saying. What we want to do here is we want to factor out the thing that is bothering us by saying this. We want to factor it out. So we're going to say, if I factor out a 4, 4 divided by 4 is 1. Right? Yeah, quite literally, minus x squared over 4. Yes. When I said it's going to seem quite bizarre to us, I literally mean it's going to seem quite bizarre to us. Okay, so the 4 became a 1 and made us happy, right? And now, right, I can say that that's dx over square root of 4, right? Because multiplication I can separate. Square root of 1 minus x squared over 4. I don't need the parentheses there, but I decided they made me happy. Square root of 4 is 2, and I can move that out as 1/2 dx over square root of 1 minus x squared over 4. Right? Now I have 1, I'm happy with the 1. Except now what? What's wrong? What happened? We now have x squared over 4, and x squared over 4 is no longer making me happy. We fixed the problem and we made a problem, but I heard the solution. Yes. Right? We learned how to fix that in the last problem. Okay, so I can say 1/2 integral of dx over square root of 1 minus x over 2 squared. Right? See people shaking their heads like, you've got to be kidding me. No, I'm not, actually. Oh, trust me, this is less than half of what I mean when I say this is the obnoxious section of the year. Okay, now, we know how to fix that. This is u substitution, right? U equals x over 2. du equals 1/2 dx. You multiply by 2. And actually, I'm not even going to multiply by 2. I'm going to leave that right as it is. You know why? Yeah, I have a 1/2. It's right there. Get that out. Occasionally life works out in your favor. Not always, but there it is, right? So that goes right there. And this goes right there. So we end up with the integral. Remember, this part went there, so I now have u. 1 over square root of 1 minus u squared. Oh, look how pretty that is. Sorry, I get excited. And then we just get our sine of u plus c equals the arc sine of x over 2 plus c. There you go. Whew. Okay, well, now, got it done? Okay. I am going to caution you against using formulas in textbooks that claim to have all the answers. They lie to you. I'm not kidding. There are formulas in textbooks that lie to you over and over and over again. I've seen kids screw up things on exams because there are formulas and textbooks that claim to have all the answers, so I don't teach them completely live. I'm not kidding. Just don't do it. Just don't look at textbooks and lie. Okay, I'm not kidding. Okay, ready? All right. I'm not sure why all of my examples are not spelling. That's okay. This is under conjugated. 16 minus 9x squared. This one should be relatively clear what we do here. Right? And then we're going to get to the real problem. Okay. We'll be okay. I promise. Okay. Tell me what to do. First we take the 16 out. And I'm going to factor it out right away. And then this moves out as 1/4. Meanwhile, back home on the inside, we like the one. This is killing us. We make it a U. All in the square. And then set up U substitution, yes. U equals 3x over 4. Du equals 3 over 4x. Ooh, but wait. Dx. I'm having trouble. But last time it worked out so nicely. Okay. So 1/4 we have, 3/4 we don't. So what do? Okay. Well, 4 over 3 du equals dx. Sure. Okay. And the 4's die. Die. We get 1/3. And we get 1 over square root of 1 minus u squared du, and well, that's pretty. 1/3 arc sine plus 3/4 x plus c. Feeling good? Okay. Can I do a hard one now? Okay. Incidentally, I haven't put bounds on any of these. But remember, the bounds wouldn't really change anything. numbers instead of arc sine of right, and then you would just get numbers instead of. So I would plug in like, you get arc sine of numbers. I have to find that. Okay, now. This is where it gets fun. Okay, here we go. Integral. No, sorry, I did that wrong. Fine. What went wrong here?
You don't like the full effect. We either don't like the 4x or we don't like the 6 story there.
Either way, I wouldn't like that 4x.
We don't like that 4x.
Oh, wait. Let's not do that. Oh no, I did copy that wrong. I'm copying half of this problem and half of that problem. Sorry. Give me a sec. Okay. You're still not going to like it any better, but let's try this again. Okay. Okay, all of one problem at a time. You ready? Okay. X squared 4x 13. Okay. Huh? Much better. Okay. No, it's not better this one. No, it wasn't doable. This thing's doable, I think. Unless I did it wrong last time. I hurt myself though. Okay, ready? Okay, who remembers complete the square? No, it's not. It's fun. I've been doing it with Algebra 2 kids. Yeah. Okay, so I'm going to rewrite this outside the integral for a moment. Ready? X squared plus 4x. And then I'm going to put the 13 over here. Okay. Complete the square is this thing that I always argue in Algebra 1 is totally useless. And then you get to Algebra 2 and it stops being totally useless when you get to Algebra 2. No, it really does. Complete the square is the concept that you have these pieces of a function, a quadratic function, and you want to make them into perfect square trinomials, right? So that you can make them into, you can make them into something like x plus something all of it squared. Is the idea, right? So in order to do that, remember that the idea of like x, right? X plus 7 all of it squared. The idea is you square the first one, to square the last one, and then for the middle, you multiply the 2 and double it, right? So the 7x, double it is 14x. And that's the idea, right? Okay, so this 4x right here is where the 14x would be. It's the multiply the 2 and double it piece, okay? So what we need to do is we need to figure out what goes here. Okay. So this guy, if it were in here, it would be Well, we'd cut it in half, and we would square it. So if I cut it in half, I would get positive 2. Square it would be 4. It doesn't always work out to be exactly the same. It just happens to in this case. Okay. So I cut it in half, square it, and I get plus 4. Right? Okay. The thing is, I can't just add stuff, because you have to keep everything the same. Right? This is America. In America, we have equality. Right? But in this case, in America, we have equality. What we do to one side, we do to the other doesn't work, because there's no equal sign. I can't do something on one side and then do it to the other. So equality in this case is not I do to one side and do to the other. It's what I do to one side, I then undo on the other. So if I add 4 here, I'm going to subtract 4 here. Because then I'm not actually helping anybody, because I'm going to help them here and then hurt them here. I think of it like, you know those commercials for Sour Patch Kids? Right? First they're sour, then they're sweet. And I hate those commercials because they annoy me. First they're sour, then they're sweet. Well, I guess first they're sweet, then they're sour, but you get the idea, right? That's what you're doing here. Okay? You must be sour and sweet in the same equation. Okay, now what you're going to do is you're going to take this guy and you're going to rewrite it. This is x plus 2, all of it squared. Okay? And if I check, it works. Square the first one, square the last one, multiply the 2, and double it. And then you put that guy together. 13 minus 4 is 9. Getting mad yet? Now I'm going to put it back in my integral. And I'm going to put it back 9 plus x plus 2 squared. And we know what to do from here. Right? Didn't apply to our problem. Remember our goal. Our goal is to get it to what does this look like?
Yeah.
Arctangent, which is 1 over 1 plus x squared dx. We need to get rid of the 9. We know how to get rid of 9. 1 over 9, and then 1 plus x plus 2 squared over 9. Yes? Okay? Yeah. Oh. Okay, never mind. And then, still continuing here, right? I make this guy into my friend, right? So I say, equals, I move the 9 out. 1 over 1 plus x plus 2 over 3 squared. Okay. Use substitution. Okay. U equals x plus 2 over 3. Du equals 1/3 dx multiplied by 3. 1/9 integral of 1 over 1 plus u squared du. And die. And 1/3 arc tangent that kind of problem that makes this whole section sort of unfriendly. So, yeah. That's all I have. And we can do some more examples and we'll have homework and